Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and all the students. Welcome to Pusat Academy YouTuber, bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let us begin by reciting a prayer according to your own religions. Let me introduce myself. I'm Teacher Tan from College Matrikulasi Selangor as the moderator of the day. We at the Pusat Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So are you ready? Let me introduce our teacher for today's lesson. We have Teacher Kong from College Matrikulasi Perak. We are now live on Teacher Kong's channel. Please support her by clicking subscribe button now. The topic of today's lesson is electronic configurations. And together with us today, we also have Teacher Vivi Lau from Pusat Tingkatan 6 SNK Tinggi Klang, who is the control host in charge to ensure the smoothness of our lesson on technical support, and Cikgu Shannon from College Matrikulasi Pulau Pinang as the observer to ensure the smoothness of our lesson today. So before we begin, I have a few reminders to all of you. First, please pay attention to the lesson. Stop chatting and use the chat sessions wisely. Second, regarding on the certificate link, the link will be given to you at the end of the class. Please use eDidik account when you fill in your particulars. And make sure to listen to the passcode given by me throughout the lesson and fill in the form within the time limit, which is 30 minutes. So without further ado, let's welcome Teacher Kong. Oh, before that, the passcode is A4. The first two passcode is A4. Okay, the first two passcode is A4. Okay, so without further ado, so let's welcome Teacher Kong to start the class. So Teacher Kong. Teacher Kong, your mic is mute.
Oh, okay, sorry. Okay.
Okay.
Okay, hi everyone. Okay, I'm Teacher Kong. Today, before we start our lesson, right, I would like to introduce my chemistry pre-U team. Okay, who led by Teacher Shannon. Okay, so here is Teacher Vivi Lau, who is control host for today. Teacher Tang, okay, our moderator. And okay, today observer is Cikgu Shannon and Cikgu Marwa and myself. Okay, so first of all, right, okay, I will introduce pre-U team. The subject is mathematics, who led by Teacher Ying. Next is, okay, this one is biology team, who led by Cikgu Faiza. And then next, physics team, who led by Madam Rosmaya. And account and economy teams, who led by Madam Fizi. So this is my poster. Please remember, follow us every Sunday, 3:30 p.m. Okay, so I'm from Perak Matriculation College, have around 10 years experience in teaching chemistry. Okay, so here is my working place, College Matriculasi Perak. Please remember, subscribe my channel. Thank you. Okay, so before we start, let's do some recap of previous lesson. Previous lesson, we learned about quantum number. So quantum number, there are 4. Principal quantum number, the symbol is N. Angular momentum quantum number, the symbol is L. Magnetic quantum number, the symbol is M. And then the last one is electron spin quantum number. The symbol is S. Okay, so these 4 quantum number is very important for today's lesson, which is electronic configuration. Okay, we just do some revision for this one. Okay, principal quantum number, right? It determines the energy and the size of an orbiter. Okay, it started from n equal to 1 until infinity. If we check, right, when n equal to, compare the n equal to 1 and n equal to 4, the size is bigger, for the orbiter size is bigger. At the same time, the energy increase as well. For angular momentum number, okay, it got a lot of name, azimuthal subsidiary orbital quantum number. Okay, how to determine the value of L? It depends on n. It's from 0 to n minus 1. Okay, the function of angular momentum is to determine the shape and type of orbiter. So as we know, right, there are S orbiter, F subshell, P subshell, and D subshell. Okay, so n determine L. Okay, when n equal to 1, L equal to 0. When L equal to 0, we should know, right, it's S subshell. Okay, and then when n equal to 2, L equal to 0 and 1. If 0 is 2S. If L equal to 1 is 2P. Same for when n equal to 3, the possible value for L is 0, 1, 2. So if 0 to 3S, if 1, 3P, and if 2, 3D. Okay, the third one, magnetic quantum number, is from negative L through 0 to positive L. The function of magnetic quantum number, right, is indicate the orientation of orbiter in the space around the nucleus. It's determined by the L value. So L value determine the M. Okay, so the possible M value, right, okay, can be calculated by 2L plus 1. So for example, when L equal to 0, okay, you try to substitute 0, then the answer is 1. That's why only one possible orbiter. So that's why M equal to 0 and represent the S subshell. Okay, for P, right, okay, when L equal to 1, so we try to substitute 2 times 1 equal to 2 plus 1 equal to 3. That's why there are 3 possible orbiter, which are negative 1, 0, and positive 1. So total there are 3 possible orbiter. So okay, the L equal to 1 represent the P subshell. Okay, when L equal to 2 represent the D subshell, right, there are 5 possible value. Okay, 2 times 2 plus 1 equal to 5. So the possible value are negative 2, negative 1, 0, positive 1, and positive 2. And then the last one is the S value, which is positive half represent clockwise. Okay, and then the negative half represent the anti-clockwise. It shows the motion of an electron. Okay, so this one is a summary. Okay, just a summary for n equal to 1 to n equal to 4. When L equal to 0, what is the subshell? And then there are how many orbiter? Okay, we have to know, right? Orbiter, one orbiter. This is only one value for m equal to 0. So there are 2 electrons because one orbiter can place 2 electrons. Okay, so one follow clockwise, another one anti-clockwise. So that's why positive half or negative half. Positive half is the upwards, upwards, and then the negative half is downwards arrow. Okay, so now let's start our focus of today's lesson, electronic configuration. Okay, so first of all, right, what is electron configuration? It shows how the electrons are distributed among various atomic orbiter. Of course, we must know the electron number. This one we can refer to proton number because when an atom, the proton number is equal to the electron number. That's why we can check for the Bliss constant there are how many electrons for a certain element. Okay, because proton number is equal to electron number. So for example, hydrogen atom at the ground state with 1 electron, so the proton number equal to 1. Okay, or we say proton number equal to 1, that's why hydrogen there is 1 electron. So when we write down the 1s1, right, we must know the meaning of 1s1. 1 is indicate the n value, means the energy. Okay, S is referred to the subshell. Okay, S is when L equal to 0. And then 1 is referred to the number of electrons in the orbital or subshell. Okay, we must know, based on here, right, we must know, okay, for S orbital, maximum 2 electrons. For P orbital, maximum 6 electrons. Okay, and then for D orbital, maximum 10 electrons because 5 orbital times 2 equal to 10. Here, 3 orbital times 2 equal to 3. Here, 1 orbital times 2 equal to 2. So that's why later we will know, right? Okay, why is 1s2, Y is 2p6, and so on. Okay, now we would start, right? The first method to write down the electronic configuration, which is orbital diagram. Okay, we can represent the orbital diagram by using box, platform, or concentric circle. But if between these three, right, which one do you think is the easiest one? Of course, okay, platform, because just a single line, single line, single line. So I will encourage you all, right, use the platform to perform the electronic configuration for orbital diagram. Okay, oxygen with 8 electrons, that's why, okay, I will place 1s2, 2s2, 2p4. Why we put like this? Okay, later I will tell you why. Okay, the second method is SPDF notation. Okay, we straight away write down 1s2, 2s2, 2p4. Okay, the green color is represent the principal quantum number, and then the blue color is represent the azimuthal quantum number, which is L value, or we say a subshell. And then the 2, 2, 4 is the number of electrons in the subshell. Okay, these are the rules we are going to learn how to assign electron to an orbital. First, our foul principle. Next, Pauli, wait, something wrong. Suppose it's Pauli exclusion principle. Okay, the third one is Hans rule. Okay, there is a typo error over here. Exclusion is missing. Pauli exclusion principle. Please take note. Why I do like this? Because I want you all right, take note. Later you check. Hans with apostrophe S. How about Pauli? Okay, let's check. Okay, the first one, our foul principle. Based on the definition, right? Okay, electron fill in the lowest energy orbital first. What means by lowest energy orbital? And other orbital in order of ascending energy. Okay, let's check for this diagram. Okay, so start from 1s, 2s, 3s, 4s, 5s, 2p, 3p, 4p, 5p, 3d, 4d, and so on. Okay, maybe some of you might ask me, Madam, why there is no 1p? Okay, why there is no 2d? Okay, because right, when n equal to 1, what is the value for L? Okay, the answer is 0, right? Okay, and then the m value equal to 0. And then the s value is equal to positive or negative half. Okay, so if you check from here, right? Okay, when n equal to 1, L only equal to 0, meaning that it's 1 s orbital. Okay, if 1p is not accepted, because when n equal to 1, only L equal to 0 is accepted. Because p orbital is represented by L equal to 1. So that's why there is no 1p. Same for here. Okay, when n equal to 2, okay, so L equal to, okay, equal to, so n minus 1, so 2 minus 1 equal to 1, so it's 0 or 1. So that's why only 2s or 2p are accepted. That's why there is no 2d. So this is the reason why. Okay, so, okay, I hope you all can get this concept. Okay, let's continue. Okay, yeah, I hope you all get this concept. So that's why there is no 1p or 2d. Okay, so next. Okay, we start with 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Okay, so we have to follow the sequence. Electron fill in the lowest energy orbital first and others orbital in order of ascending order. So the sequence or the order of filling orbital is started from 1s and then follow this sequence. So that's why, right, before you start, I encourage you all draw this staircase diagram. 1s, 2s, 2p, 3s, 3p. Students, very easy to get confused for this one. 4s and 3d. But write 4s first, then only 3d. Because according to this relative energy level of orbital, right, okay, 4s has lower energy compared to 3d. Okay, okay. Please take note. And 5s has lower energy compared to 4d. So if according to our file, we have to fill in the 4s orbital first, then only followed by 3d. Okay, After alpha, what is the next? Okay, yes, just now exclusion is missing. So, and then did you notice there is no apostrophe s for Pauli exclusion principle? Just straight away, Pauli, okay, capital letter because it's a name, exclusion principle. Okay, the focus on P here, P must be capital. So Pauli state that, okay, Pauli exclusion principle state that no two electrons in the same atom have the same 4 quantum number. What means by same 4 quantum number? Okay, means the N, L, M, S, the set of quantum number, right, is not the same for each electron. Okay, in other words, each electron must have different set of quantum number. So for example, we check for helium atom. Helium atom with 2 proton number, so that's why it has 2 electrons. So we will straight away fill in 1s2. So for the first electron, right, okay, we check among these 3. The first one, 2 electron with same spin. Okay, this one outwards, this one with downwards, and then this one with opposite spin. By right, the 1s2, suppose is like this. This is the correct answer. So we can, impossible for both of the electron will have the same spin. Okay, for both positive or both negative is impossible. So this is what Pauli exclusion principle states. So even though they have the same N, L, M, S value, N, L, M value, but the S is different. Okay ya? Walaupun N sama dengan 1, L sama dengan 0, and then M sama dengan 0, sama. But last kali, S sama dengan positive half and negative half. So if we check the set of quantum number of these 2 electrons is different. Okay, this is what Pauli exclusion principle states. Okay. So now we check for Hans rule. This is third rule. Okay. So when electrons are placed in a set of degenerate orbitals, what means by degenerate? Okay. A group of orbitals of identical energy. For example, the 3 p orbitals and the 5 d orbitals. Okay. These orbitals considered as degenerate orbitals. Each orbital is filled singly with the electrons of parallel spin. Okay. What means by singly an electron of parallel spin? Later I will show you all. Before the electron occupied the orbital in pairs. Okay, look at this example. Okay, we try. Okay, for here, right? Okay, this is carbon. Carbon with proton number equal to 6, so there are 6 electrons. So first of all, right, I will assign 1s1, 1s2. So this is 1s, followed by 2 electrons for 2s. Okay, now 6 minus 4 remain 2 electrons. How are you going to place the another 2 electrons? Okay, we have to place singly with the electron of parallel spin. So meaning that I have to singly fill first. Okay, I cannot fill like this. This one cannot. Because according to Hans rule, right, I have to singly fill first. And then with the same, with the parallel spin. Okay, maksudnya arah yang sama. Okay, so number of parallel spin equal to 2. Okay, so that's why this is what Hans rule say about. Okay. Okay, yeah. Okay, this is, yes, have to singly fill first. So this is Hans rule. Electron occupies separate orbital rather than pair. Okay, so let's, after we learn about these 3 rules, right, let's check, okay, our understanding for these 3 rules. Okay, student, for each of the following pair of hydrogen orbital, indicate which is higher in energy. Okay, let's check which one is the higher energy. Okay, we start with A first. Okay, we can, what, 1s or 2s? Okay, let's check. Yes, 2s. 2s with higher energy. 2p and 3p, of course, is n equal to 3 is larger, right? 3p. Okay, how about 3dxy and 3dyz? 3dxy and 3dyz. Because we know, right, for d orbital there are 5, dxy, dyz, dxz, and then dx square minus y square, and then dz square. Actually, right, for these 5, they are having the same, okay, same energy. That's why both of them is the same. Okay, it's the same. Okay, and then 3s and 3d, of course, is 3d, SPD, right? So d is higher. 4f and 5s, 4f is higher. If you try to arrange according to the alpha, you refer to a diagram, 4s is higher. So for the higher energy, right, we have to use the sign larger than. If the same, we use equal. Okay, this one larger than. 4f is larger than 5f, 5s. If you check for the energy level or the alpha rules, right, 4f is larger than 5s. Okay, next question number 2. Okay, write the orbital diagram of beryllium when z equal to 4. Simple, right? Okay, because I cannot see your answer, okay, so you try to choose among these 3, which one is the correct orbital diagram of beryllium. Okay, I give you around 20 seconds. So then try to check A and B, which one is the correct orbital diagram of beryllium. The proton number given is equal to 4. Oh, very good. Okay. I saw the answer, Nuha Izzati. B, is it correct? Is it B? Okay, Faris, B. Okay, let's check. Yes. Okay, the answer is B. Okay, if I up level, okay, why? Then how do you explain why? Okay, normally, right, the first part question will be asked you, oh, which one is correct? Okay, how to write a correct one? And then the question straight will ask you, explain. Then how do you explain? So try to explain why. Okay, so then try to write down the reason why the answer is B. Okay, this one I give you around 40 seconds because just now 20 seconds you can check write down the answer A or B, because this one you need to type, right? So that's why I give you 40 seconds. So why the answer is B? How to explain? Okay, yeah, madam, wait for your answer. You can type something and then explain why you choose the answer is B, not A. Okay, Hafiz, Faris, Izzati. Okay, try explain why the answer is B but not A. Teacher Tang, any answer from the student?
Faris said that it follows the Afbal's rule.
Ausbau rules. Okay. Others answer?
Maybe they are still writing. Izzati said that occupy the orbital in place first.
Okay. Just now Faris gives the answer, follow the Aufbau rules. And then Izzati say must occupy the orbital in pair first. Okay. So which one is the correct one? If you refer to the definition, right, must pair up first is which rules? Okay. We always have to refer the 3 rules, Aufbau, and then Pauli exclusion principle, and then Hans rule. Okay. Okay, let's check. Okay. Okay, very good. Just now Faris say have to according to our file. Okay. And then Izzati say, right, is okay, must pay out first. Must pay out first. Or is it must pay out first? Okay. Student, please take note. When you say about according to our file principle, okay, you must explain what is the definition of our file principle. After you explain what is the definition of our principle, right, you must explain in details based on this question. So for example, according to alpha principle, electron have to fill the lowest energy orbital first and others orbital in order of ascending order or increasing order. So this one is the explanation, is the definition. Okay, if you only write this right, maybe you cannot get the marks yet because you didn't answer the question. You have to answer according to beryllium. According to this case, beryllium element. So you have to mention. So the fourth electron. So this one is the fourth electron, right? Is filled in 2s orbital, but not filled in 2p orbital. So just now Izzati said must pair up first. Actually, if you according to alpha principle, right, not pair up first, but you have to fill in 2s first before you fill in 2p. Make sure 2s with 2 electrons first, then only followed by 2p. So this is what alpha principle state. Okay, and then okay, at the same time we have to follow the Pauli exclusion principle as well. Why? Because for the second means the one, this is the second electron, and the fourth electron, right, have to fill up with opposite spin. So meaning that one upwards, another one is downwards. Okay, so must fill up with opposite spin. So this is according to Pauli exclusion principle. Pauli exclusion principle say that each electron must have 4 different set. Okay, must have different set of quantum number of 4 different quantum number. Okay, or have different set of quantum number. So please remember when you choose the correct answer. Okay, and then you must know how to explain. When you explain, right, you have to choose the right rules. Maybe alpha principle, maybe Pauli exclusion principle, or Hans rule. Okay. In this case, Hans rule is not applicable because they not involve the degenerate orbital. So only alpha and Pauli exclusion principle. Give the definition first and then explain in detail according to the question. Okay, I hope you all get this, huh? Okay, so finish for question number 2 and then know how to explain. Okay, why you choose B is the correct answer. Okay, question number 3. Again, which of the following is the correct orbital diagram for the ground state electron configuration of nitrogen? Which is Z means the proton number equal to 7, and you have to explain. Okay, so this is the second question. Similar question like question 2. Okay, but just the proton number is different. So how are you going to assign the electron for n equal for n nitrogen atom? A, B, C. Okay. So then let's try this one. Okay, because just now just 4 proton number right now becomes 7 proton number. Okay, means 7 electrons. So I give you 30 seconds. A, B, C. Which one is the answer?
Teacher Kon, Izzati already answered C. Izzati answered C.
Izzati answer C. Okay, good.
Hafiz also answered C.
Okay, also C. Okay, we'll
Yeah,
try. Let's check.
And then Zhi Xing also answered C.
Okay, let's check. Is it C? Okay, is it C? Okay, before I give you the answer, right? Is it C or not? The C, okay. Please try to explain why not A and B. Okay, so then, okay, try to think why the answer not A or B. Okay, and then the answer is C. Why you choose C? And then what is the reason? Okay, you not choose A or B. Okay, try to explain. Besides, you know how to choose the answer, you must know the reason why you not choose A or B or why you choose C. Okay. Okay, this one I give you more time because I want you all right. Tell me the reason why you don't want you're not choosing A as the answer or not choose B as the answer, and then choose C as the answer. Okay. Okay, I think we can go for advertisement first, right, Teacher Tang?
Okay. So shall we stop for a while for the advertisement? We will be back.
Yeah. Yeah. Try and think.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Before we continue, so I will give you the third code. So the third code for today's class is 8. Okay, so the third code for today's class is 8. 8. Okay, so Teacher Paul, you may continue the class.
Okay, thank you, Teacher Tang. Welcome back. Okay, the first one, right? A knows the answer. I give you some hints. The problem is here. Okay, so this one. So it not obey which rules? Okay, so then can you tell me for this? Okay, yang ini tak ikut peraturan yang mana? For this one, not obey which rules? Okay, so try to tell, madam. Okay, this 2s orbital, right? The electron placed wrongly. Okay, suppose it's opposite spin, right? So it not follow which rules? Okay. Oh, I saw Faris. Okay, Pauli exclusion principle from Izzati. Let's check. Yes, very good. Does not obey Pauli exclusion principle. Okay, so now you have to explain. Okay, try to give the definition. No two electrons in the same atom have the same 4 quantum number. Means the NLMS impossible is the same. Okay, tak mungkin akan sama. So the second electron, right, for these 2s, right, suppose, okay, filled with opposite spin. So the second electron, okay, sorry, second electron of the 2s orbital have to fill in with opposite spin. So it should feel like this. With the negative spin, it should be like this. One upwards, another one downwards. Okay, good. How about B? What is the problem of B? Here. So for B, does not obey which rules?
Just now for East, it wrote Hans rule.
Hans rule. Okay, let's check.
Yeah,
very good. Does not obey Hans rule. Okay, so again, we have to give the definition. When electrons are placed in a set of degenerate orbital, yes, 2p, this called degenerate orbital, px, py, pz. Okay, px, py, pz are the degenerate orbitals. Each orbital is filled singly first with the electron of parallel spin before the electron occupied in the orbital in pair. So meaning that, okay, so there are 3 electrons for the 2p orbital. So you have to fill in like this. So you have to fill in, okay, 1, 2, 3. Have to singly fill first. So the third electron means the third electron of this one, right? Okay, of the 2p orbital have to fill in here first. And then this electron cannot, okay? Okay, so you have to explain. The third electron of the 2p orbital have to fill in at the third column of 2p orbital with parallel spinner. Make sure parallel spinner. So meaning 3 of the electron placed upwards, okay? And then not the first column of the 2p orbital with opposite spin. Okay, this is the reason. So you must state again what rules not follow or what follow which rules, give the definition and explain according to that question. So for example, this question is nitrogen, so you have to explain based on this situation. Okay, so the answer, yes, the answer is C, obeys Pauli exclusion principle and Hans rule. Because the electron of the 1s and 2s orbital, right, they feel in pair with singly spin, with opposite spin, and then the 2p orbital fill in the degenerate orbital, okay, with the parallel spin, and then parallel spin before the electron occupied the orbital in pairs. Okay, so you must remember the definition of these 3 rules: Aufbau principle, Pauli exclusion principle, and Hans rule. Okay, Hans rule with apostrophe S. Okay, so keep in mind, S subshell, right? Okay, the maximum electron is 2 and S2. P subshell, the maximum electron is 6 and P6. Okay. D subshell, maximum electron is 10 and D10. And then F subshell is 14 and F14. Okay, the S2 and P6, this one is normally for SPDF notation. And then here is for the orbital diagram. So always remember, each atom make orbital can only accommodate or place a maximum 2 electrons. Okay, so now we try another type of question. Okay, what are the possible quantum number for the last outermost electron of chlorine? Okay, I give you some clue. There are 7 electrons for chlorine because the proton number of chlorine is equal to 17. There are 17 electrons for chlorine because the proton number of chlorine is 17. So for this kind of question, what is the step 1? Yes, you have to write out the electronic configuration. Okay, so you must write out the electronic configuration first. Always remember, must follow alpha. If you're not familiar, first, right, you have to write down 1s, 2s, 2p, 3s. Sorry, yeah. Okay, you have to write down 1s, 2s, 3s. Okay, and then I know 4s, and then 2p, 3p, 4p, and then here 3d. Okay, you have to follow. Okay, 1s2, then 2s2, then 2p6, 3s2, 2p6, 3s2, and then 3p, 3p5. Okay, so check. 2, 2, 6, 10, okay, 17. This is S. So this is the electronic configuration in the form of SPDF notation. Okay, this is the first. You have to apply the alpha principle if you're not familiar first. If you're familiar, you can straight away 1s2, 2s2, you know the answer. So this is the electronic configuration. So the outermost electron, right, okay, valence is 3s2 and 3p5, but the outermost we refer to the 3p. Okay, now the question asks about what? Quantum number, okay, possible quantum number for 3p. So, and check. We know, right, n equal, for 3p, n equal to 3. So in this case, okay, class, I know when n equal to 3, okay, L equal to 3 minus 1. So equal to 2, 1, or 0. But in this case, it's 3p subshell. So 3p subshell is referred to 1. Okay, 3p subshell is referred to 1. Okay, so that's why L equal to 1 and M equal to -1, 0, positive half, and then S equal to positive half or negative half. So you check the answer. So total there are 6 possible answers. Okay, the last electron is 3p, and then the possible quantum number, okay, so this is the answer. Okay, because the question asks about possible quantum number. So you try to answer n equal to 1, L equal to 1, and then M, S as well. If I change the question, okay, yeah, again, Corina, write a set of quantum number for the last outermost electron in chlorine. So what is the answer? Student, let's try. Okay, I just give you check again. So this question is related with chlorine 17. The question is, what are the possible quantum number for the last outermost electron? Now 4b, I change, write a set of quantum number for the last outermost electron in chlorine. Okay, so what is the answer? I give you around 20 seconds to answer this question. Question 4b, after we discuss for 4a, now I proceed with 4b. Okay, still using chlorine with 17 electrons, but now the question changed to write a set of quantum numbers. Okay. Any answer from the student, Teacher Tang?
Hafiz having the n equals to 3, L equals to 1, M equals to -1, and S is positive half.
Okay. So this is what we know just now. This is still the same. Okay, the possible quantum number. Okay, this is what we answer in 4a. And then now, yes, very good. Okay, one of the answer from Hafiz is correct. 3, 1, -1, positive. Okay, 3, 1, +1, and then positive half. So Hafiz give this answer. Yes, correct. Okay, congratulations, Hafiz. You get the right answer. Because the question just want a set. So you give one set is enough. Okay, but there are 6 possibilities for this answer. Okay, because the M value equal to -1, 0, positive half. At the same time, the S value equal to positive or negative half. That's why there are 6 possible answers for this case. So, but you just need to give one. Okay, some of the students, they're so excited they answer or give all the 6 answer. If you write down comma or and, right, is wrong because the question asks a set. So you just give one set is enough. If you really want to write everything, right, so you have to put the sign or. But time consuming. That's why I just encourage you, all right, just give one answer setup. Okay, yeah? I hope you all can understand. Okay. Is there any 4C? Yes. 4C. How many electrons in the outermost shell? Okay, 4C. Based on this question, how many electrons in the outermost shell? What is the answer? Okay, student, try to answer how many electrons in the outermost shell for this case.
Izati answer 5.
5, okay. Madam give you some times. Okay, try. Decide 5. Got others answer? Hafiz, you can try. Faris, you can try. How many electrons in the outermost shells? Okay, I highlighted the outermost shell. So you check which one is the outermost shell.
Faris answer 7.
7, okay. Here. Outermost shell is equal to n equal to 3. N equal to 3 is the highest n value. Okay, so in this case, right, the answer, yes, equal to 7. Okay, well done for Hafiz and Faris. Good try for Izati. So the answer is 7. Be careful, because right, just now is outermost electron, we refer to 3p, but this one is referred to outermost shell. So for the shell, the highest n is n equal to 3. So 3s2, 3p5, that's why the answer is 7 electrons. Okay. Okay, now let's try question 5. The electron configuration of a neutral atom. So neutral atom, this is neutral atom with the electronic configuration. Okay, so the question asks, write a complete set of quantum number for each of the electron and then name the element. So this question actually is a simple question, but it's quite tough because you need to state each of the electrons, meaning that you check there are how many electrons for this case. 1s2, 2s2, 4, 3p6, plus 6, 10. Okay, 3s2. Okay, 3s2, 12. So there are 12 electrons for this neutral atom. So you have to write a set of quantum number for each. Okay, you have to write that all. And then you must estimate, okay, this proton number, total 12 electron, that's why proton number equal to 12. So when Z equal to 12, what is the element? Yeah, so I know, okay, now is Z equal to 12. So what is the element for Z equal to 12? Okay, the proton number. Okay, so many answer, right? So I show to you all. Yeah. Okay, so this is the answer. Okay, be careful. Before you start to write the set of quantum number, right, you must take this one first. Okay, wajib tulis benda ni dulu. Okay, bracket NLMS equal to. Okay, so for certain book, right, they will show like this. Okay, I random choose the first electron. It will show the N equal to 1, L equal to 0, M equal to 0, and then S equal to positive half. Okay, you can write the answer like this, also acceptable. Or you just state NLMS, okay, remember N, comma, L, comma, M, comma, S, and then bracket equal to. So first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. So this is the set of quantum number of these 12 electrons. Okay, so the element with proton number, okay, equal to 12 is magnesium. Okay, okay, get the idea? Okay, if you want to specific, right, some of the students say, 1s1 is this one, so 1s2 is this one, 2s1 with this one, 2s2 with this one. Okay, yes, you can do like this. Okay, this one you state clearly, so also acceptable. Okay, let's try for question number 6. Okay. Okay, this one is a bit trickier. Indicate the total number of p electron in nitrogen with the proton number of 7. Okay, let's try. First of all, you must know how to write the electronic configuration first. So 1s2, 2s2, 2p. Okay, 4 already, right? So 3. So there are how many p electrons? What's the answer, student? Okay. Waiting for answer, I will proceed with S first. I will help you all to write the electronic configuration for S. Okay. Please let them know there are how many p electrons for nitrogen. Okay, seems like nobody answered yet. Try. For the question 6a, okay, p electron in nitrogen atom. I showed you already, right? So this is the only p orbital that for the nitrogen element. Yeah, there are how many electrons?
Exactly answer for 6A is 3.
Yes, very good. 3 electron. Because here 2p3. So there are 3 electrons. Okay, now we proceed for S electron in silicon. So with proton number equal to 14. So I want to, okay, now 1s2, 2s2, 2p6. Okay, 10, 3s2, 2, and then 3p2. 1s2, 2s2, 2p6. Okay, always check, is it 14? Yes, I assigned the 14 electron already. Now the question asks S electron. So S electron here, here, here. So what is the answer?
Faris' answer for 6B is 6.
6, very good. Okay. Let's move on to 6C. So it's the same 1s2, 2s2, 2p6, 3s2, and then 3p4. So in this case, the question asks about D. 3D electron in S. S is sulfur. So is there any 3D electron for sulfur element? S2, 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 2p6, 3s2, 3p4. Is there any 3D electron for sulfur element? So, wow, I saw the answer already. Faris say
Izzati
0.
and Faris say 0.
Okay, very good. Yes, this is another type of question that might ask about the SPDF notation, about the electronic configuration and quantum number. Okay, so yes, okay, 2p, there are 3p electrons, and then for silicon, 1s2, 2s2, and then 3s2, that's why there are 6 electrons. And then for sulfur, there is no d electrons. Very good, good try. Okay, just now 4, 6, 16, right? Okay, now we move to higher level. Okay, the vanadium with the proton number of 23. So this is one of the transition method. Okay, now the question asks about write the electronic configuration of the following transition method. Okay, and then with ion 5 positive. Okay, in this case, right? Okay, we do it as usual. Have to follow alpha principle, Pauli exclusion principle, and Hans rule. So okay, if you're not familiar, right, as I said before, so you must start with 1s, 2s, okay, write down everything, follow the alpha one, and then arrange. So we straight away check the answer. Okay. First of all, right, you must write down the electronic configuration for vanadium atom. Okay, you must write down the electronic configuration for vanadium. Okay, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p5. Okay, so total 23. Then, okay, you must rearrange. Okay, I will try to rearrange according to n value first. Okay, because why we need to arrange according to n value? If you check, right, there are 4 shells. So this one n equal to 1, n equal to 2, n equal to 3, and n equal to 4. So this one is the nucleus. So the attraction of the nucleus between the valence electron means the outermost one is n equal to 4 is the weakest one. If I want to remove electron, right, I sure will remove the first electron from the 4s2, followed by 4s1. Then the third electron from 3d3, the fourth one 3d2, and then the fifth one 3d1 to achieve octet. So in this case, because vanadium 5 positive, I know I need to remove 5 electrons. So these are the electrons that going to remove. But always remember the first electron is from 4s orbital. So then only we'll get the answer. Okay, vanadium 5 plus with this electronic configuration. Okay, don't try to 23 minus 18 then start to arrange. Cannot. You must write down the electronic configuration for the atom first. Then only try to remove one by one. Okay, and then the question tend to ask you which one is the first electron to remove. So you must know. Okay, now we move on to the next topic, the anomalous cases electronic configuration. There are two elements which are chromium and copper is not follow alpha principle. Okay, so this is the alpha principle diagram. So we know we need to follow according to alpha. Okay, so copper and chromium. Okay, because due to the reason half field and completely field or full field orbital, which is more stable, and then the electron. Okay, so argon. Okay, this one argon. Why is represented by argon? Okay, if you check for certain book, right, they will replace the electronic configuration, means the front part, right, with the noble gas. Because for here in this case, 1s2, 2s2, 2p6, 3s2, 3p6, right, it's the electronic configuration of argon. That's why it's straight away represented by argon. Okay, so total here there are how many electrons? Here is there are 18. Okay, the remaining 6 electron, right? Okay, by right. Okay, by right is 4s2 and then followed by 3d4. This is according to alpha. Okay, but the actual one, the one electron from the 4s will transfer to the 3d orbital, because want to achieve the half field orbital, because half field orbital is more stable. Same concept for this case. One of the one of the electron from the 4s orbital will transfer to the 3d orbital in order to achieve 3d10, which is the full field or completely filled orbital, which is more stable. Okay, so how to answer this kind of question? First of all, right, the first part you must write, what is the expected electronic configuration? So the expected is 4s2, 3d4. Okay, this is SPTF notation. And then this one is the orbital diagram. So it depends. If the question didn't mention, right, okay, you just choose either one to answer. But next, you have to tell the examiner or answer the question. The actual one, suppose is 4s1, 3d5. Or you try to arrange according to n value, 3d5 or 4s1. Both acceptable. Okay, these two acceptable. Okay, or represented by the orbital diagram. And then the third point, you have to explain why. Because extra stability is gained by having the half-field 3D orbital. So same concept for copper. Okay, the expected one. Okay, you can use either one. Can answer by use. If the question didn't mention anything, you can answer in SPTF notation or orbital diagram. Okay, so it's 4s2, 3d9. This is what expected according to alpha principle. But the actual one is one of the electron from the 4s orbital transfer to 3d. So it becomes the 4s1, 3d10. Okay, because due to the extra stability of the fully filled 3D orbital. Okay, again, you can try to arrange according to n value. Means n equal to 1 first, then n equal to 2, n equal to 3, then only n equal to 4. Because the 4s1 will be removed first. If the question asks about which one is the first electron to be removed. Okay, so always remember extra stability is gained by the half-filled 3D orbital, and the energy of the 4s and 3d is quite close and quite similar, causing one of the electron in 4s jump to 3d. As I said just now, the 4s2 orbital, right, the one electron from the 4s2 transfer to 3d orbital, become 3d5, the half field, or become the 3d10, the full field for copper. So due to the extra stability. Okay, so I think that's all for today. Before we end, right, okay, you try to answer. Oh, I give you the first answer already. Oh, sorry. Okay, this is a simple question. Electrons are filled in the orbital according to the following order. 1s2, 2s2, 2p6, 3s. Okay, 3p. Always remember 3b followed by 4s, then only 3d and 4p. This is according to alpha principle. Okay, let's try exercise 2. Okay, I have to press carefully here. Okay. Okay, which of the following does not obey Pauli exclusion principle? Okay. Then try exercise 2. Which one not obey Pauli exclusion principle? Okay, try which one? Not follow Pauli exclusion principle. But also always remember what Pauli exclusion principle state.
Izzati answer C and Faris also answer C.
Yes, very good. Wait. My answer is wrong. Your answer is correct. Okay. So typo, okay, the answer is C, not B. Okay, why? Here. And here. Very good. The answer is C. Okay. These electrons suppose fill in, okay, or opposite spin. Fill in opposite spin like this. Okay, the answer is C. Okay. How about this one? An atom containing 8 electrons in 3D. 3D, you know, right? 3D. 1, 2, 3, 4, 5. 3D orbital. Okay, are arranged according to which rules? Okay, we should know, right? First, we have to singly fill first. After singly fills, then only we want to pair up with opposite spin. So, 1, 2, 3. So among these 3 rules, which rule we are going to use to apply the 3D of the fill in the electron in 3D orbital with 8 electrons? So 8, so now only 6, 7, 8. Okay. 1, 2, 3, 1 and 2, 2 and 3, or 1 and 3. So what is the answer? An atom containing 8 electrons. There are 8 electrons in 3D orbital. So we must apply which rule in order to fill in these 8 electrons? So, okay.
Hafiz answer 2 and 3. Faris also answer 2 and 3.
Let's check. Yes, you are right. Yes, 2 and 3. Because, right, okay, you have to degenerate orbital first. Okay, and then with opposite spin. Okay, you have to remember the definition. Okay, I think next is the last question. I keep on emphasize. After we write out the electronic configuration, right, we must try to rearrange the electronic configuration according to the n value. Because based on the n value, we know with the highest n, the electron at the highest n value should be removed first. So the order of electron removal in the formation of gallium 3+ is, so based on here 3+, I know I need to remove 3 electrons. Okay, so n equal to 4 is the highest n value. So which one is the first electron is going to remove? So A, B, C, D. Which one is the answer?
Faris answer B.
Okay. Is it? Check. Yeah, congratulations, Faris. The answer is B. We have to remove the first electron from the 4p orbital, followed by 4s2 and then 4s1. Okay, I think that's all for today. Always remember, stay tuned with us on Sunday, 3:30 p.m. until 4:30 p.m. with Cikgu Shannon, Cikgu Mila, Cikgu Mama, and Cikgu Tang and me. Okay, please do remember, subscribe my channel and like and share. Thank you.
Okay. With God's grace, we are done with today's class. We have learned a lot from Teacher Kron on the electronic configuration. Congratulations to those who are able to follow the class from the beginning to the end. And thank you very much, Teacher Kron, for the very interesting lesson today. So the last 2 class code is 97. It's 97. So the last 2 class codes are 9 and 7. So before I provide the certificate link, so please off the live chat button and click subscribe button if you haven't. This is to show the appreciations to Teacher Kron for giving you free class today. So don't forget to click the bell button too, so that you won't miss any new videos and live classes from Teacher Kron. So if you like the class today, so please click like and share it to your social media friends. Let's share the knowledge you received today with your friends. Sharing is caring. When you have finished, type done in the chat session, and then the certificate link will be given. Okay, so once again, I would like to thank Teacher Kong for the interesting lesson. So thank you to Teacher Vivi Lau and also Cikgu Shannon for being with us today. So I think that's all from us today. So see you all in another session. So please do remember to stay at home. So goodbye everyone. Have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.